It is my pleasure to introduce today's session moderator, Ms. Jyoti Jain. Ms. Jyoti Jain, a dynamic English educator with over 16 years of experience in inspiring academic excellence and holistic growth. She is a mindfulness coach training people to lead stress-free life. As a CBSE master trainer, Jyoti has played a pivotal role in shaping teaching methodologies and curriculum development. Her roles as moderator and senior coordinator for the British Council activities for International School Awards underscore her commitment to raising education standards at an international level. Beyond her classroom achievements, Jyoti is a fervent advocate for holistic learning. She helps both students and professionals manage stress and improve performance through mindfulness, meditation, and breathwork techniques. As a skilled communication trainer, she empowers individuals to express themselves confidently and effectively. Jyoti Jain's blend of extensive experience, innovative teaching, and dedication to holistic development marks her as a leader who inspires others to achieve their full potential. Hearty welcome, Ms. Jyoti Jain. Please proceed. The stage is yours.
Yes, Ms. Jyoti, over to you.
Thank you, sir. Thank you for your kind words. Hello, everyone. Good evening, esteemed educators and participants. I am Jyoti Jain, an educator and mindfulness and communication coach by passion. It is my honor to serve as your moderator for today's important session on 20 effective strategies for teaching mathematics. As we gather here on 7th May, a date that gently reminds us of strategizing effectively. The whole world knows about it. It becomes even more meaningful to reflect upon the implementation of effective strategies, truly mirroring around all-round development of every learner in mathematics, nurturing not only their intellect, but also their values, creativity, and skills. In words of John Dewey, education is not the preparation for life. Education is life itself. And today's discussion truly resonates with this sentiment. On behalf of Extra Mile Education and Training, I welcome all the educators and participants who are committed to building a future-ready generation. Extra Mile stands a beacon of quality professional development founded under the visionary leadership of Dr. Abdul Salam as a part of Bharat Transformers and Academic Group, BTAG. With its unparalleled pool of resource persons, Extra Mile excels in delivering customized online and offline training across India. I would like to express my words of gratitude to Abdul Salam, sir, and Extra Mile Education and Training for providing me this wonderful opportunity as moderator for today's session. So, before we proceed, I would like to share a few points for the smooth and interactive experience. If you have any queries during the session, please feel free to post them in the chat box. For an interactive experience, you are encouraged to clear your doubts by asking questions. Kindly use the virtual hand raise button and wait for your name to be called before speaking. And regarding certificates, kindly visit the website www.btac.in. And if it's your first time, sign up. It is very user-friendly portal, and you will receive your certificate via your registered WhatsApp number. Now, before we move on to technical learning of the day, I would like to introduce the key members of BTAC team, starting with Dr. Abdul Salam. Dr. Abdul Salam is a visionary founder and CEO of Bharat Transformers and Academic Group and Extra Mile Education and Training. He is also a distinguished CBSE resource person and master trainer with a wealth of contributions to the education sector. As an assessor of National Accreditation Board for Education and Training under the Government of India, Dr. Salam brings a wealth of knowledge and experience. On behalf of all the participants, I warmly welcome Dr. Salam to address the audience. Over to you, sir.
Thank you. Good evening, everybody. Good evening, Biju sir, Dr. Beena Prakash, and all the educators who have joined. First of all, welcome to External Education and Training. Thank you for joining. I'm very happy to see lots of educators who have joined, and the room is full. Lots of educators from across India, various parts of India and abroad. Thank you so much for your passion for learning. And let us, be very thankful to Dr. Beena Prakash for offering this session. Thank you, ma'am, for this.
My pleasure, sir.
Yeah, and Dr. Beena is the right person. When I requested madam to give us some tips for transacting mathematics effectively, so that maths being always a hard nut to crack, and is a scary subject. So there should be somebody to help us, handhold us in the transaction area. And madam is the right person who is leading personality in the education field, and also is a member of NCRT mathematics textbooks. So this session is going to be very much enriching to everybody. Madam will be able to help us with lots of inputs, different strategies for teaching maths very easily. More importantly, very, what do you call, effectively, interestingly. So thank you so much, madam, once again, and hearty welcome to everybody once again. Stay back and enjoy the session. Over to Jyoti ji. Jyoti ma'am, over to you.
Thank you so much, Dr. Salam, sir. Thank you for your encouraging vision that keeps us moving towards excellence. Next, I would like to introduce Mr. Biju S. Pillai. Mr. Biju Pillai has an extensive background in education, serving as the principal of several reputed CBSE schools. He is also the co-director of Extra Mile Education and Training. Sir, we are truly honored to have you here with us. I now request Mr. Pillai to share his thoughts with us.
Thank you, Jyoti ma'am. Most respected resource person, Beena Prakash ma'am. Today is resource person, program director, Dr. Abdul Salam, and all other respected maths teachers on the dais. Very happy that our platform is full with 300 participants. So that much serious maths teachers are to get the most important 20 strategies from our respected resource person. And being mathematics, it's very crucial subject where children need to be made alert, made interesting, the subject more interesting, so that right from the beginning itself, if there is no foundation, it will be just like Tare Zameen Par. We have seen that child sitting inside the class. So it's most important from the right beginning of the class itself. We have to give a very good base so that the children will start loving the subject, loving the teacher, and automatically throughout their lifetime, mathematics will be a proud subject in their life throughout without having any fear. So let this day be the day for all the maths teachers to gain more and more knowledge, so that they can use more strategies to make their children more effective into this particular subjects. And I heartily congratulate Beena ma'am also to have a wonderful evening with all your maths teachers. Thank you, ma'am. Thank you, Jyoti ma'am.
Thank you, sir. Thank you, Mr. Pillai, for your valuable insights. Thank you so much. It's now time to introduce today's distinguished resource person, and it's my proud privilege to introduce her, Dr. Beena Prakash, PGT Mathematics and a dedicated educator with an exceptional career in shaping mathematics education. She holds an illustrious profile that includes member of NCERT Text Development Team for new Class 6 and 7 mathematics textbooks, contributor for learning objectives for secondary schools for NCERT, member of National Achievement Survey, NAS, Learning Outcomes Development Team, an active member of All India Mathematics Teachers Association and Delhi Association of Mathematics. Since 2019, she has been conducting live, online, and offline classes for class 7, 8, 9, 11, and 12 under PM eVidya initiative, and has delivered 9 offline training sessions for CBSE teachers across Bhopal and many more through online platforms. She regularly conducts GeoGebra training sessions as a certified GeoGebra trainer. Her dedication has earned her multiple recognitions, including the Best Teacher Award by NCTS Junagadh in January 2024. Her Open Educational Resource, OER, was selected by CEMCA along with 174 entries, and she has presented her research paper at NERIE Shillong. Her vast experience as an educator, administrator, trainer, and mentor has been instrumental in shaping progressive learning ecosystems. Today, we are fortunate to have her here to guide us through 20 strategies of teaching mathematics aligned to National Education Policy 2020. Dear participants, let us now immerse ourselves in today's learning journey. I now invite Dr. Beena Prakash ma'am to enlighten us with her insights and experience. Over to you, ma'am.
Good evening, everyone, and thank you for such a nice introduction. Let me see how I can keep up my promise. Thank you, Salam sir, for giving me this opportunity. I'll try my best to deliver what is required. Is my voice audible?
Yes, ma'am, you're audible.
The screen is there?
It's appearing. It's taking a little while. Yes. Yes, it is there.
Can you see the screen?
Yes, ma'am.
Let's little adjustment here and there. To start with, we will be building mathematical minds, not creating calculators. That's what the theme is. That is, build mathematical minds, not just create calculators. To start with, what is actually mathematics? Mathematics, it's a language. Why? Because it allows people to communicate for trading, construction, farming, cooking, everywhere. Everywhere we see. And wherever we see in all these, we don't see it as a symbols or formulae. We see it as a language. The laws of nature are written in the language of mathematics. Everybody can see the screen? Can you all see the screen? There are 4 different pictures put together. These are 4 different pictures. But when you see this pattern, you'll find that the pictures represent the same thing. The patterns represents the same thing. Am I clearly audible? Jyoti?
Yes, ma'am. You're very much audible. You're clearly audible, and the screen is there.
Let us have some interactive session. So I would like to take up response from the participants. What do these pictures represent? If I move clockwise, the first one, second one, third one, fourth one, anybody quickly can write it in the chat box and Jyotiji can give me the information. Has anybody written anything? Just one of anybody, please raise the hand. Let us have a communicated class. All pattern looks same. Any information?
Yes, ma'am. The participants are actually talking about various patterns of nature, root pattern, or earth, branches, lightning, nerves.
Yes. So what we see, these are all patterns, isn't it? They are all in the nature. This pattern, if you see the reverse, this is a pattern. This is branches, veins, lightning. All they represent the same pattern. So they are from different parts of nature. But it is again speaking mathematics language that is in nature. So it's a nature that shapes perception, develops concepts, enables to think. It's the science of structure, order, and relation. It has evolved from elemental practices of counting, measurement, and describing shapes of objects around. It deals with logical reasoning, quantitative calculations, critical, abstract, and spatial thinking, problem-solving ability, communication skill. It provides an effective way for mental discipline. It is not just repetition and memorization of formulae. It's a thinking that has to be understood, interpreted, communicated, conceived, and imagined then to be perceived. Now, most of us, like most of the parents, we have heard parents saying that my child practices the question thoroughly. He does it 3 or 4 times. Before the examination, he takes up the exercises many times, but still finally is not able to score. So what is actually he's doing? He's practicing only repetition part. And we have seen that in higher classes, the questions, they don't come as such. It's not the same thing. There's a change in the question. So the repetition part that he has learned for practice for the examination is not going to help him. So repetition and memorization of formulae is required for the beginning level. After that, it needs to be understood. And it has to be interpreted. Only then we can take up the correct way to solve the questions. So it is a thinking that has to be understood, interpreted, communicated, conceived, imagined, and then it has to be perceived. Only then we get the result of it. Mathematics literacy is must for any career growth. Believe it or not, for any career growth, that much literacy is required. Mathematics basic literacy is required. Every examination that a child appears for has a mathematics paper where he has to prove certain level of mental ability. So that literacy part has to be taught in the lower level. So for that, what all requirements are there, we'll be taking up in this. Any data presentation has its authenticity if it is supported by a data analysis. Mathematics helps in developing curiosity and increases the power of observation. So it's considered as a sense that we have, sight. If I do not wear the specs, I will not be able to see anything. So as my sight is weak, so I have done something to improve or to see things around. So that's what we need to take up for the children also. It's not that everybody will be able to imagine or perceive the things. We may have to make them think to perceive the things. That is, thinking is important to get the end result. So let's deal with the strategies. This presentation outlines key strategies for the students' engagement in mathematics. It also emphasizes the importance of collaboration, presentation, and equity. So let's start with the strategies. The first one, visualization and reason. The first one is visualization and reasoning. What do you see? What do you see in this picture? You see some picture here? What is seen in it? This is a final picture of an elephant. This final picture of elephant has been drawn through these steps. That means the child must have started with this structure, then added something more to it, finally added, and all these things he must have visualized it. He must have thought, because he'd been asked to draw the picture of an elephant. So to get the picture of an elephant, he needs to know where to start from. So he must have drawn some certain oval, circle, added more figures to it, and then he gave a little more structure to it, and finally he got this image. And when he gets this image, he finalizes the image with the help of a color pencil, color pen, or something. All these structures he uses pencil. These are pencil structures that is required to get to this information. So that's what we were discussing. Like, we need to understand. You have to start thinking, and it needs to be understood. That is the final structure of the elephant. How is it to be drawn? The child has to start thinking. Any random combination will not come to the end result of the elephant. So that's a pencil structure that he has to draw. So he'll be using different known figures that he is aware to get this. And then the final structure. Once this structure is made, once he makes the structure, I have shown it with the 4 figures. Actually, it is not the 4 figures. It will start from, it will be on it only. The same figure will have the structure, and then this will be overlapped on it. And finally, he'll draw this. And once this figure has been drawn, what he does is he erases the pencil structure. So this part is not seen. So this is what we have in our classroom also. We give them the formula. We tell them the formula. I think there is some disturbance outside. Can you hear that disturbance? There is some sort of, okay, anyway, it's okay. So these structures are not there in the notebook. When they write, we insist the child to write the things in a step. We just give them the formula. We are trying to give them they apply the formula and they get the answer. But when they're practicing the questions, are they able to identify what is the process that they have gone through? This process of taking up the final shape of the answer, that is very important. That's the thing that we need to tell the students, how to start to get to the solution. So that is the key of learning, is understanding that the pencil is the pencil structure. Fine. Now let's see this. Can you all see these circles? There are different circles. And I think the certain things will not be clear, but I'll make it clear. This is 1. This is 2 written inside a circle. 3 written inside a circle. That's 4, number 4 written inside a circle, then 5 written inside a circle, 6, 7, and so on. So we have numbers written up to 60 written inside a circle. Now, okay, there is a circle. Can you hear me? There is a circle here. There is some procession going outside. I don't know what it is, how. There's a circle here which is not seen here because it has no color on it. The next circle has number 2 written in it, which is in red color. The third circle, a non-colored circle, has 3 written. The number 4 the circle represents number 4, but we find that the circle has been divided into 2 parts. The next circle is not divided. The third circle, next 6th circle again has been divided. So what is that you can visualize from this figure? Can anybody put it in the chat box? What is, if it is seen clearly, or do I have to explain it once again what it is having? These are having numbers. The first row has numbers 1 to 10 written inside a circle with different colors. There are circles which has been divided and divided with the line that is diameter is dividing it. It's from the center it has been divided. So we have these 2 equal parts. These 2 are equal part, which represents number 14. This number represents 13. This number represents blue 11. So these are different numbers written on it. So can anybody tell me what is seen in this figure? So what interpretation do we have in it? Yes? Anybody has any reason written in chat box?
Yes, ma'am. Our participants, they are saying that these are primary numbers that are not divided. These might be fractions, continuous numbers, prime factors, colors in numbers which are same, maybe equivalent fractions, parts of a circle, numbers that are assigned to circle, colors, prime and composite numbers with factors, odd and even numbers,
So these are the different
expressed
answers
prime
you are getting, no?
numbers.
These are
Yes,
different
yes.
answers
So
that you're
these are the
getting.
answers that are there in the
Yes,
chat box. I'm
that's
reading
what
it
I'm
out
saying.
for
So
you.
these are different types of numbers. So each circle is representing certain facts about that number, isn't it? The fact of that number is informed through these circles. So what fact information do we get from this circle which has a 3 written on it? Or what is the information that we get with this circle which has 2 and 2 written, or 3 and 2 written, or 3, 3, 3 written here, or a 3, 2, 2, 2 and 7. 2 represents red color. That is the number 2 has been, it's there. It's a part of the circle. 2 is a part of the circle. 7, the color 7 represented this circle. It's a part of this. So what we find from here is we are able to give certain information regarding numbers. As I got the information from Jyotiji, it is saying that they are representing fractions. Fine, they are representing fractions. We can deal with fractions here. We find that this circle has been divided into 2 parts. This circle has been divided into 3 parts. Now this again has been divided into actually 3 parts, but where 2 parts are of the same type. So many things can be taught through this diagram. The foremost thing that we can see from here is we can read out the factors of each of these numbers. They are all the prime factors that you can see. Into how many factors they can be divided is very clearly seen in these figures. I think, is it clear to all? So the diagram which has 4 of 2s and 1 3 says that there are 4 factors of 2 and 1 factor of 3. What is that number? 48. The number 7 and 7, that means they are dividing into equal parts. That means square root of 49 can also be written, understood from here. Square root of 49 is 7. So likewise, you can interpret so many things from this figure. And there can be different reasons for explaining each of this. So how visualization helps us to take up the things. Now I'll give you another video. Just look at this video. Most of us have taken up this topic in the class, which says that a piece has been divided into 3 parts. That's 1 on 3. And again, the next part has been divided into further 1/3 of it. That is giving us 1 upon 3. See, what is happening here is the whole has been divided into 3 parts. The next whole, we are adding something to it, plus 1 upon 3 whole square. That says that the next part has further been divided into 3 parts. So isn't it dividing it into 3 parts? 1 part, second part, and third part. So we take the first part of it. So this represents 1 upon 3 square. The next is 1 upon 3 whole cube, which says that the next part, further part that we had of the 3 has been divided. That is, this part has been divided into 3 parts. And the next 1/3. So this keeps on going. So how far we can take up? It can go to any extent till wherever you can show. See, it's very clearly explaining certain things. That is, it is going till infinity. And if you remember, participants, if you remember, this is a series whose sum is found through the formula. That means we need to identify what series is it. The series is a infinite geometric series. So when you get to have, when you have a geometric series, we first find its first term, which is 1 on 3. Then we look for the ratio, common ratio. The common ratio is the second upon the first. That means 1 upon 3 whole square round 1 on 3, which gives us 1 on 3. So the common ratio of this is 1 on 3. Hence, what will the formula for infinite series? It's A on 1 minus R, which gives us 1 on 3. Can you all visualize? This is again another thing that I keep telling my students. we have a habit of expressing everything on some, that is, they need to see. Please avoid making them see everything. Let them visualize also. Only then they'll be able to connect the things. So visualization of steps is also very, very important. So here I'm making you all understand the visualization part. That is the sum of this. If you remember, the sum of this is A on 1 minus R. So 1 on 3 upon 1 minus 1 upon 3. So now how do we read it? It's something upon difference of that is 1 minus 1 on 3. That gives us 2 on 3. So it's a ratio 1 upon 3 upon 2 upon 3. That gives us the answer 1 upon 2. The sum of this is 1 upon 2. So look at this video, what we are getting from here. It's a very beautiful video, which I got it from the net. So this is 1 upon 2. Isn't it half? The whole thing has been divided into 2 equal parts. The sum of this infinite series is 1 upon 2. Okay. Now we move on to the next. Sorry. Next is giving them the idea of helping them in number sense. That is, mathematics, as everybody knows, is through numbers only we have certain informations. So everything deals with numbers. So if everything deals with numbers and basic operations, the child, when they reach 7th, 8th, 9th, they should be very familiar with certain type of numbers. And that will help them to handle the computation, that is large computation, easily. Like this first information is divisibility rule from 2 to 15. I've written 2 to 15, but I've not mentioned 15 because we know if we have to see that if we have to see that a number is divisible by 15, we just need to see whether it's divisible by 3 and 5. So that is already mentioned here. So I've written it from 2 to 15. I'll give you a rule. Now, all these has a rule. So rule for divisibility by 2, 3, 4, 5, 6, they are all known to everyone. 7, 11, 13 may not be known to many. But I'll tell you how to get the rule of divisibility by any number. I'll take up this number 15687. Can you all see the number?
Yes, it's visible, ma'am. Yes, it's visible, ma'am.
Yes, it's 15687. Now, how do we find out that this number will be divisible by 7? Let me take up 7. Divisibility by 7. Now, how do we look for the condition for divisibility by 7? What is the rule? That is, I'll give you a rule. Please make sure that you understand this rule very clearly. So as this rule is applicable for every number, it's not only for 7, it's applicable for every number. Like we are looking for certain information which will help us. Like you have this number, the divisibility by 11 rule says that we add up the odd alternate digit numbers. Like 167 is added. So addition of 167 gives us 14. Fine. Then we take the addition of next alternate digits, that is 8 and 5. So next alternate digit is 5 and 8. So they add up to 13. Now, how do we check the divisibility by 11? What we do is we take 14 minus 3. We take the difference of the two numbers. 14 minus 13. It is 1. We check that the resultant should be divisible by 11. Is this number divisible by 11? It's not. Hence, this number will not be divisible by 11. Let me take up this calculator and show you. It's 15687. It's 15687 divided by 11. What answer are we getting? It's a decimal number. What does it represent? It says that it is not divisible. So this is the verification that whether the number is going to be divided by 11 or not. So that's the rule for 11. Now for 7 or any other prime numbers, what we do is the rule, I'm discussing the rule. The number that we have, you multiply it by a number so that in its units place, you get a number which is closer to tens number, that is either 10, 20, 30, 40, 50, and so on. So we know that number 3, 7 multiplied by 3 gives us 21. It can also be taken up as multiplied by 7. There's something scrolling up. Sir, can you see this setup professional? Shall I delete this? Cross it, sir? It has been, shall I cross it?
Which one, ma'am?
Okay, I crossed it. Anyway,
Okay.
is there any disturbance? Just let me know. Now, when 7 is multiplied by 7, we get 49. So what is that I said? Any number which will be closer to the tens number, that is, it is closer to 20, this is closer to 50. So how do we get this as 20? Minus 1 will give us 20, isn't it? And this is plus 1, we get it as 50. So what we have as a number, that is the number that we get from here, is dividing this 20 by minus 10, and that gives us minus 2. Dividing this number by 10, that gives us plus 5. So the rule is we'll take up through these numbers. I'll start with this number minus 2. The rule for divisibility of 7 is we'll break up the number into 2 parts. The whole number and the digit part will be separated. Only that is there in the units place. That will be separated. So we have it as 1, 5, 6, 8. Then what we do is this units number, place number, if I'm using this number minus 2, I'll multiply it by minus 2 and get the product as minus 14. Minus 14 says that I'll have to subtract it. So when you subtract it, you get 4, 5, 5, 1. This process is to be continued. The next is 1, 5, 5, 4. 4 will be multiplied by minus 8. It will be 1, 4, this is 7. Then 7, this is again further taken up. 7 multiplied by minus 2 gives us minus 14. So minus sign here. So the remainder that we have is, that is when you add the 2, we get it as 0. And whatever is this number, that number should be divisible by 7. 0 is divisible by 7. Hence, the number 15687 will be divisible by 7. 1568 is divisible by 1567 is divisible by 7. Check. That's how we get the divisibility. Now, if you're using 5 as the number, then we'll have it as plus 5. So that means we'll multiply 7 by plus 5. That gives us plus 35. So the number that you're going to have is plus 35. So we'll be adding it. But this process continues. So this is a process which we need to inform the children at the level of 6th, 7th, 8th class, so that in case they come across such big numbers, we are always seen that we do come across such big numbers in computation for first either finding the LCM, just HCF, or using it as a part for mensuration part or for statistics. For all those reasons, we should be knowing. So children are wasting their time for such computation. So if we tell them these rules, I think they will be able to take up this calculations little faster. So that's what we have as the next. And there are certain computation strategies also. Most of the teachers, we are aware, mathematics teachers are aware of all these strategies, but we should be telling them very frequently so that they're able to save their time. Like the square of the number, the square of any number, faster calculation is going for this computation. That is nearest number again, where we can have zeros, that is 23 minus 3 square, so plus 3 square. So they are using this algebraic expression a square minus b square to compute it. So when they compute it, you'll find that it is just this evaluation, that is, this comes out to be a number which happens to be first 1 digit, because in the units place, it's a 2-digit number, but its units place will always be 0. So that way, the computation part will be little easier. So next, if you have number as 103 whole square, so what is observed in it? The number that we come across is just add 103 to 3, that gives us 106. 2 more zeros added to it, plus 9 will be the answer. So immediately such evaluation or computation can be taken up. So these things need to be informed to the children. Next is the multiplication of 198 by 5 or 15 or 165. Now all these facts, these little facts has been introduced in 6th class textbook. So I will insist that all teachers should be taking up this computation part very seriously in every lesson that we have with numbers, so that the children don't waste their time, because the learning of multiplication, division and all is done in much lower level, that is 3rd, 4th, 5th. But we find that they do make mistakes, and because of that they are losing their marks. So that's now, next is mathematics is the foundation of logical reasoning. Building strong strategies ensures students transition successfully. Now you all can see something on the screen. Can you all see something on the screen? It has been divided into 2 parts. I have just taken up some representation for the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. So they assume that these are the representation for the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now the question that I'm giving you is, can anybody write down or tell me? Just a minute. Immediately, can anybody tell me what number I have written? What is the number that I have written? I'll repeat my question. These are representing certain numbers, numerals, 1, 2, 3, 4, 5, 6. So if that is so, what number is this? When we write it in the normal form, how do we write it? We do not have the representation of 1, 2, 3. In case we have these as a representation, then according to this, how do we write this number? Has anybody written this? Jyotiji, can you tell me from the chat box, is there any teacher? Or let me know if anybody has written it.
Yes, so many answers are coming up, like 2105, 2456, 2354, 4150, 6150.
Okay, now I'll give you a, see, what is this saying? This is a, again, this is something we need to understand. We have to draw the elephant. That means you have to answer the question that I have given you. For this, you will have to look for the way to draw the skeleton. So if I've said these represents digit numbers from 1 to 0, so do you think the child will be able to remember these symbols? This, okay, they've been learning all this, we've been learning it. But if suppose someday, if it has been coded as this, how do we decode it? We need to understand the structure in it to decode it. So what structure is hidden in it so that we can decode it very easily? The one which we used to play in our young days. Look at this. Now start with this 6, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what does this represent? This is this part which is 6. What will this represent? 1, And what does this represent? 5. And as there are only 9 numbers inserted, a 0 has been given a new symbol, that is a different symbol. So this stands for 6150, 6150. So that's the thing that we need to decode to the children, so that the question given in different forms, because we have to stress on the competency-based questions. Competency-based question says that whatever is given in the textbook or whichever book they have, we have to be little different from that for giving them the question. We cannot exactly give them. That is only 20-30% that is given from the text. We have to make them understand how to decode the things so that they're able to take up the solution. Okay. Now another task for the teachers. This is, it's giver or pancake, which is cylindrical, has a radius and some thickness. There is an offer from the shop. A small pancake size is 5 centimeter radius and height is 2 centimeter. The cost of it is 150 rupees. And the large pancake has double its radius and height is 2 centimeter. The cost is also 400. The question is, which offer is better? The 2 small or 1 big or both? Any response from the class participants?
Yes, too small.
Too small. Whoever has answered it, can anybody explain why you have said too small?
Can you please write the explanation in the chat box? Or
No, you
can
just
raise your hand?
speak it out. Please speak it out.
Yeah.
What made you say that the too small will be better option?
If you raise your hands, we will unmute you so that you can
Yes.
speak it out. Anybody interested? Please raise your hands.
Any response? See the logical part in it. You'll get to know.
Ms. Radha is writing height is same, cost is more for large.
Cost is more for large. Fine. So you go for 2 small ones. It is 300 rupees. Definitely it is economical, 300. And the one which is the larger one is 400 rupees. Isn't it? Yes. So what we have seen is the smaller pancake is to be understood through its volume. That's why I given height. Has this as its volume because it has a cylindrical shape, isn't it? And the larger one is by 10 square multiplied by 2. So what we see in this, what is that we see in this? The volume of the larger one is equivalent to 4 times the volume of the smaller one. So don't you feel that there's something we are missing? You are going to pay 300, fine, 300 rupees. But you're going to get only half of what actually the big pancake is, isn't it? Twice of it means 300 rupees. Whereas one large can is of 400 rupees. So 4 of the smaller one, if you buy, won't it be 600 rupees? So which is more economical? So what is that we have to analyze? In all respect, we need to make them understand, analyze the thing so that they are able to break up, synthesize, to create the answer. That's the Bloom's taxonomy. They know what it is. It's a formula. They know how to apply. They will apply everything. But That's again in the lower level. To go higher, they need to work out, they need to analyze it. How, which will be economical? It looks like that the smaller one, 2 for 300, will be better option for 400, which is larger one. So these things we need to tell the students to analyze. Then comes the inquiry-based learning. Again, this you see, inquiry-based learning. I think most of us have seen one video which was very viral for some time, quite some time ago. That is a person having a chocolate bar with different segments in it. He breaks one part of it, rearranges the chocolate. Actually, the chocolate has been divided into different groups, and then he rearranges, keeps out that one block out. He finds that he's still able to make that out, that is a 4x3 chocolate. It's a similar question here. So this is one triangle, this is another triangle, and these two are two. That is, this triangle is having 4 pieces. When these 4 pieces are rearranged, that is, you will shift the yellow one to the upper part and bring the blue one to the lower part, and then the rearrangement, we find that there's a small gap here. How is it possible to have that small gap? When the same structure, it's the same structure, same thing has been rearranged. So what exactly is happening here? How do we look at this question? How is the question to be looked at? Yes? How do we look at this question, the 2 questions? When you rearrange it, you find there's a small gap. That means in broader sense, if you look at the question, we look at the area, isn't it? That's how we find. So we find that this is a rectangle which has been divided by this particular line. So that's a diagonal of the rectangle, and we have the rectangle's area. Half the rectangle's area will be the area of this, all this together, put together. Exactly the same thing as seen here also. But the area of this particular region is -1 unit, square unit. So where are we going wrong? That is, if you are asked, if the child is asked to find the area of this particular region, immediately what is the response the child takes up? Area of this part plus area of this part, or this. That's okay. So when you look at this, you'll have to find the area of all 4 and then add up. The child takes a different route. We have different ways of learning. The child takes up a different rule. We can see that it is half this length multiplied by this length. That means half of 5 multiplied by 13. Whereas when you add up all the regions, it comes out to be different from this. So there has to be an inquiry in it. How do we have the same thing different? How is it that different? We need to show them through different ways. Can you all see this figure? This is one triangle, this is another triangle, and the other triangle piece will add on here. Now, can you see something has been added? I've added, that is, I've shifted this yellow triangle to this side. So when the triangular rectangle is shifting, we see there is a small gap here. There is a small gap here. Isn't it? Yes. That's the green triangle. I've shifted the green triangle up. I've shifted this green triangle up and brought this yellow triangle down. In doing so, this polygon of this also shifts. So that shift I'm trying to show. See, what is that you see in it? Can anybody observe this? Is it visible? Can anybody observe this? So don't you think this small margin that we see is the difference? So where lies the mistake? Where lies the mistake? Any response?
I'm just seeing the response for overlapping area of blue and yellow triangle and GeoGebra. We're still waiting for the response from the participants, dear educators. Please respond in the chat box.
Okay, I'll tell you. There is a mistake that the error that we see is we treat this particular line. Can you see this? This particular, that is the third side of the blue triangle or the longer side of the blue and the yellow triangle as one straight line. That's the biggest mistake because the triangle, so there are so many things to teach children. We can have this in the form of hand-on activity also, where they will compare the two triangles. I was just showing it through the GeoGebra. That is the two triangles that we have interchange. They are leaving a space here, gap here, which says very clearly that the triangles are not similar, because of which we cannot treat this as a straight line. They are two different segments. It is AC is one segment, CE is another segment. So that is the reason why when you rearrange it, we get a gap. That means the area of this is not to be treated as half of 13 by 5. We'll have to take it in parts. We'll take it only when this has one particular color. Either it should be one colored, that is either it should be yellow, blue, or whatever it is. So if it is in one color, then it represents the half of rectangle. Otherwise, they are different polygons which has to be added separately. So these minute informations through question has to be dealt in the class. Next is the questions to raise inquisitive level of learners. First is the closed-end questions using the Bloom's verb. That is remembering, understanding. We all know what these stand for. So remembering, understanding part. What type of lines are represented by this? It's a very basic thing. The child, after the chapter is over, we discuss certain informations with the chapter, that is equations of lines, system of linear equations, where we do inform the children about the conditions of different types of lines that we see when we draw graphically. When this line is drawn graphically, what is observed is the lines will be either a parallel line, perpendicular, or intersecting. So they are aware of the information when to have what type of lines. So seeing this information, they'll come to know that they represent the parallel lines because the ratio of A1 on A2, B1 on B2 is not equal. They are equal, but they are not equal to C1 on C2. So this is a direct question. The next question that we have for the next verb that we have, that's understanding. Based on this, we can frame a question, write an equation of a line which is parallel to this. A line is given. So these are the questions which are asked as MCQ or short answer questions. So the information they already have, that's the information that they're carrying. That is A1 on A2, B1 on B2 should not be equal to C1 on C2. So they'll frame the line. So it can equation that is 3x minus 7y is equal to change the constant. So that application part, they are not known. It's known to them. Next thing is the third verb that we have. That is create and applying. So how is it applied? To find the value of k. So now to find the value of k. Now for this, what the child has to do is get the same structure as we have of the first equation. For that, he will have to work out. That is, he will be taking, the child will take up the second equation as minus kx plus 4y is equal to 24, and then take up the operation of A1 on A2 equal to B1 on B2, but not equal to C1 on C2. So it's very clear 12 and 24 will never be equal to 4 upon 4. So therefore, it will be a parallel line. So accordingly, k's value will be obtained. So this is the first three verbs that we have. Then the next open-ended question. What are the open-ended questions that we have? Now, very often our children might have asked, or we put across the question for any equation, why is it that with this condition we have no solution? Why is it that the lines are, when you draw the lines graphically, we get parallel lines? And how is it that this has infinite solution? Haven't we come across such questions, or haven't we put such questions? So what is the reason? So this is an open-ended. We need to tell the students, how do we get this? That is the condition that we have no solutions or infinite. Now the next is, what if A1 on A2 is equal to C1 on C2, but not equal to B1 on B2? When we get such situation, like A1, I'll take up the equation 3x plus 4y is equal to, suppose we have it as 8. Let me have it as 8. The other equation is 3x minus 4y is equal to 8. What is that you observe in it? What is that we see? When A1 on A2 and C1 on C2, that's the constants are equal, but that's not equal to B1. That's the coefficient of y, it's different. See, A1 on A2 and B1 on B2, they are not equal, but A1 on A2 is equal to C1 on C2. What we find is the two lines, they intersect at x-axis. So this is an open-ended question. We need to understand, make them understand what happens if we reshuffle the condition. So based on this, you can again frame a question, write an equation such that the point of intersection is on y-axis. We find that it is on the x-axis. So how do we get it on y-axis? We'll have to have the coefficient of y and constant same, but different coefficient of x. That's all. So these are the types of questions which we need to frame to make them understand. So how can we create a vision for mathematics? How can we do all these things? By creating a vision for mathematics with the vision of mathematics. Knowledge is not. The next is giving the autonomy of learning. Maths idea should be taught in context of a story. Thus will promote integration of multiple content areas. Use literature to introduce, teach, or reinforce concept which results in advanced thinking. Now let's just go back. How do we actually teach? It's actually a traditional method that we have is the procedural fluency. That is, we depend upon how fluently the child can follow the steps that has been taken up in the class and how easily he can work it out without making any mistakes. So that's the ability to follow the algorithms, rules, or the formula without necessarily understanding why they work. This method tends to produce students who can perform computations but struggle to apply, because we always have the third, fourth, fifth, sixth level of Bloom's taxonomy in the question paper for competency-based questions. So there the children, they struggle to apply the starting point of drawing of the elephant. That is what is to be taken up to construct that elephant. I have written something on the screen. 3. Can anybody read this statement? The first part, which I am highlighting. My cursor, I'm showing it through the cursor. Can anybody read it?
Shall I go ahead with that?
Yes, ma'am. Yes, sure.
3 plus 5 is
Yeah.
what?
3 plus 5 is what? Yes.
Yeah.
So in saying this, what have we said? Please analyze what we have said. you have decoded this symbol. 3 plus 5, that's a symbol that has been decoded. But what exactly 3 plus 5 stands for? Or the next statement. What is the next statement?
The next statement states 2 into 3 into minus 4 plus 7.
It's not multiplication. I'm sorry if it is looking like
3x.
multiplication.
Okay.
It's 3x
3x
minus
minus 4 plus 7 is equals to 11.
Yeah. Again, saying this, 2, it's actually, we are actually decoding what is represented here. That's not the way to teach mathematics. We need not decode it. The child will be able to write its own symbol. So
Sorry to
instead of
interrupt
reading-
you, ma'am. The participants are asking why there is no is equals to sign.
No,
here.
I've not. I've just put a question mark. How do we read the statement? Is this one statement which I've given a statement, open-ended question? That's what is the. How do we read it? I'm not asking what it is. Getting it? I'm not asking what it is. How to read the statement?
Okay.
So that's the important thing that I've said here. That is the procedural fluency that we have. Here we just have told them 3 plus 5 says that you're just decoding that symbol, which has a meaning, which has been told to them, that's fine. But if you get a question, if the child gets a question where he has been asked to take up a word problem, like he has 3 oranges and 5 oranges in another basket. And if you're asked to put together the two, find how many oranges he has in together, how will he be able to decode it as this symbol? That's the reason we need to use a language to explain this fact. The language says that 5 added to 3 or 3 added to 5. Instead of reading it as 3 plus 5, we need to read it as 5 added to 3. What is it? What is when 5 added? What will you get when 5 is added to 3? The word added should be represented by this sign. The child should be able to decode that the word addition is represented by that. It's a symbol. So please don't read every time the symbols that is there. We read it as the statement of the question. Like here also, we need to get the sum as 11. The sum of two quantities. It is sum of two quantities is 11. What are the two quantities? It is something unknown. That is 3 times, 4 less than 3 times an unknown number. Twice of it and 7 added to it will give us 11. So that's the information that we are giving. So we need to frame those languages to express the question. Instead of reading it as 2 times of 3x minus 4 plus 7, please read it as 7 more than twice of. It's a bracket. Of stands for bracket. That means the rest of the statement will be in bracket. It is 7 added to twice of 3 times an unknown number or 4 less than 3 times an unknown number is giving us 11. So if these languages are used in the exam class, the children will be able to handle all the word problems. So these need to be taken up from the lower level. What fraction of 1/3 is 2/5? All this is a representation we have. Now again, I've just put one question. See, this is one question which is there in the textbook. It's a question on quadratic equation. X square minus a plus b times x plus ab equal to 0. That's an equation. The question is to solve for x. So we know the procedure, the formula is given to them. Their formula that they are aware is, it is for any equation, we have ax square, that is, if you have the equation as px square minus qx plus cr equal to 0, then x value will be minus of q plus minus under root of q square minus 4 times p and r upon 2, half of the 2, half of that expression. So as per that, they have learned to apply it. Fine, that's good. The child has applied the formula. Then the child is aware there is some computation inside this radical sign. They are going for this computation. And while taking up this computation, in case, because of certain reason, if the child goes wrong in it, the child will be held up at this step. He will not come up to the step because of which he will not get the answer. So that is what I'm saying. The elephant structure will come only when the child is aware what all geometrical figures he can add up on the initial structures to come to the solution. So every time if you look for the procedure, the child may be confused. So we'll need to give them a different way out to handle the question. Now, how do we handle this question? The question says it is x square minus a plus b times of x plus ab equal to 0. Now, before we take up these questions, we are informing children regarding certain facts about this. It's a quadratic polynomial that we have taken. And the quadratic polynomial needs to be factored. So we factor it as x minus alpha and x minus beta, assuming that alpha and beta are the zeros of the polynomial, or alpha and beta, if you take it as an equation, it's the roots of the equation. Now, what are these alphas, beta? They have some relation, that is, that is, we are aware that we teach the children that it will be minus of, if you have this equation as ax square plus bx plus c equal to 0, this will be minus of b. And likewise, you have alpha beta as AC, the product of the two, A and C, isn't it? And then we rewrite this in this form. So when you observe this carefully, we find that we can directly take up this fact. We can always split the middle term. Look at this expression. If we can go for this, then why do we need to go for that procedure that has been told? So we need to give the liberty to make them understand that they can have, we do discuss different informations. We give all information regarding it, but finally the child has to be given the authority to answer the question. See how easily we are getting the answer. So there is no big calculations in complex calculations in it. Without that complex calculations, we are able to manage the questions. So these authority that they need to give them, we need to give them the liberty to, that's autonomy of learning. Fine. Shall I go ahead now? Now my question for this is very clearly written. 326 is divided by 2 of 842 divided by 4. Then we multiply 322, 28 divided by 2, or any number for, let's say, it is 464 divided by 4. We always go for the division from this in this direction, isn't it? We go for the division in this direction. Whereas when you're given some number, when you're given the number, like you have the number, we have this operation 116. The product of 116 and 4, when we take up the multiplication, we move in the reverse order. 6 is multiplied by 4, carry over 2. 4 multiplied by 1, 4 plus 2, 6, and 4. We get this. But when you divide it, we divide it in this direction. Have we given the thought for that? Have we told the children why we do in the reverse direction? What is the reason for that reverse direction? Why do we take it in the reverse direction? Why division is from left to right, whereas multiplication is always from right to left? That is shown here. See, it is these green colors, they represent hundreds. So how many hundreds are there? 300s. Then we have 220 tens. 2 tens are there. And how many 6s are there? There are 6 ones. So when you have to divide it into 2, that is 326 divided by 2 says, again language, divide it into 2 parts, 2 equal parts. So if you start dividing this into two equal parts, we are able to divide it. We can divide it, fine. Here we can divide it. 3 and 3, that's another part. 10 and 10 we can divide. But when you come to this part, 100, how can you divide it into two equal parts? We need to further break it. So that's the reason why we start from this end. Or else we come to this one, 852 divided by 4. So when you look at the hundreds, tens, and the units, we find that there are only 2 units left here. How can you divide this 2 units into 4 parts? So we need to take out something from the previous. So that's the reason why divide, but we keep dividing the bigger thing to smaller thing. So we have to divide 300 first into 2 parts. So that 300 can be divided. If we divide one of the 100, is we have divided, we have taken up the 2 shares, that is, we have 100 here and 100 here. Then we go for division of the hundreds into tens. So that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, which is added with the 2 already existing tens. So that gives us 12 tens. That's what we get, no? 1 times it has been divided, 100 has been taken up. So we have it as 2 times. So we have 2, remainder is 1. So we have the 12 tens, we have the 12 tens, that's 12 tens. The 12 here is actually the 12 tens, which has been divided into 6 equal parts. And then finally we divide the 3. So that's the reason we go for division from left to right rather than right to left. Now introduce techniques to handle the concept of computation, concept as well as computation. Now what is the technique? Again, I have shown it through the polynomial, that is easy to understand. When we draw a graph of a polynomial function, we find that it is always of this shape, which is known as a parabola. So when you look at this carefully, there is some information in it. The information that we have is so what do we find? Is something visible in it? Just compare this with this. I've written this point P. P representing something, that is the vertex, the tip of the curve. Here also it's a tip of the curve. What is the tip? So this tip has that we can take up certain things from this tip to solve the equation. That is solving of quadratic equation. We all have, from the textbook, we have different ways. Factorization, then splitting of the middle term, then we have the perfect square, then using the formula. This is another method which has been very recently come out. It has been given by a mathematician from a university of, that is CMC he has given it. Is Poisson law. He has given a very easy way of factorization of or identifying the equation, the roots of this equation. It is based on this fact. The fact is that the tip that we have is the midpoint of the 2 roots that we have. Whatever be the roots of this equation, its midpoint will be a factor which will help us to solve this. So we have the sum of the roots as alpha plus beta, which is minus of b, which is b, alpha beta, which is minus 21. So the midpoint means half of it is 2, which says that the root that we have is equidistant from the midpoint. If you take this as the midpoint, one root is at this distance, the other root is at this distance. The distances between the two roots from the midpoint are equal. So let us take that midpoint, that distance as C. So one root is on the left side of 2, the other one is on the right side of 2. So it's 2 minus C and 2 plus C. These are the different roots. So if these are the two different roots, don't we know that the product of the roots, 0 or roots are minus C, that is AC, which comes out to be minus 21. So this computation gives us the value of alpha beta very easily. This is one way. There's another way of taking up. Another way is if the coefficient of x square is not 1. Usually children struggle in such type of equation. When the coefficient of x square is not 1, which is 1, it's easy. Otherwise, what we do is we just take up the same pattern. That is, we take the product of A and C, it is minus 15, and look for the factors which will give us the sum as minus 2. So we have seen the different factors. It's plus minus 1 or minus 115. That is, it's either a plus 1 or minus 15 or minus 1 or plus 15 because the product is coming out to be minus 15. Same way, it can be a pair of 3 with minus 5 or minus 3 or plus 5. So of the 4 things, we have identified that minus 5 and 3 are the roots of there. So here, I think it's not, I've not shown it, I've just highlighted it. Now I'll show it with a different color. It is actually written as x minus 5 and x plus 3. That is x minus 5 and x plus 3. So this I tell the children to write on the rough side. Just copy the same thing here. And then what we do is divide the coefficient of x square. That is, whatever is the coefficient of x square, divide that by to these numbers, that is minus 5 and 3. So what we have is the factorization of the quadratic polynomial directly. So this way, after taking up this way in the class, I found that the students are able to take up the factorization part very easily. So this is another thing that we have. Now this is a video which I got.
So the videotape on polynomials is a special attraction for these students because the shape of the ball's path looks like the graph of a quadratic polynomial. We can change the shape of a polynomial graph with high-tech computer graphics or with our own muscles. Here we see an athlete coordinate his actions to shoot a basket from the forecourt. What he's really doing is changing the coefficients of a quadratic polynomial by adjusting the positions of his hands. And it all happens in a split second. Polynomial magic.
So the parabolic shape that we see is actually the path that has been, it's an invert. That is, here we have it as ax squared plus a is positive. If we take a negative, we get the inverted. And that's the path that we see in this basketball thrower. So these are just visually, I have got these visuals, so I took it. Now, there are different types of errors. I did not take up that much. Now, can anybody give me the information regarding this? There are 10 book stacks in this shelf. Volume 1 to 10, the information that we have is each volume is 5 centimeter thick with the cover of 0.25 centimeters. That is, it has a cover. Each book has a cover of 0.25. And inside, total length, thickness of the book is 5 centimeter. So this is a picture of each book. The total width is 5 centimeter. The cover is 0.25 and 0.25. The question is, what is the different distance between the first page of volume 1 and the last page of volume 10? The first page of volume 1 and the last page of volume 10. There are 10 books, each of width 5 centimeter. Any answer? Any answer?
We have a brilliant set of educators. I think they're in the process of calculating and soon we'll get the answers in the chat box.
Any answer?
Come on, gear up, educators. We're waiting for your answers.
See, it's very clear that in between we have these 8 volumes, isn't it? So this width will be 8 5s are 40. Now the question is, from the first page of book 1 to the last page of the book 10, what is to be added?
We have the answer in the chat box, 49.5, 54.5.
How can it be 54 when we have total 10 books?
And,
So these are small errors that we commit. See, we have to really observe what we have, and then only we can analyze the thing to synthesize and create the answer. We have 10 volumes in between, so straight away we have 40 as this width. But the question is, first page, where will the first page of volume 1 be? It will be here. Where will be the first page or last page of volume 10? It's here, because we read book from this end. We open the book, we take out this book, we'll open it. So these pages that we have, that is, this part is not taken up. So to it, we add only 0.5. So the total width that we have is from the first page of volume 1 to the last page of volume 10 is 40.5. Got it? So these minute strategies to be told to the students so that they are always able to understand, again, the final product, that is the elephant, how to take up that elephant. Now you can empower these learners through collaborative. Now collaborative is, you have to be a guide by the side. Otherwise, what we had before, we usually teach as a sage on the stage, which should be avoided. Peer tutoring and group work. How do we take up the pair higher achieving students with those who need support? Structured peer work builds confidence and reinforces skills. For that, what teachers must create space for students to solve problems using their own ideas. Teachers should act as facilitators rather than instructors. Sage on the stage, no. It is guide by the side. The emphasis on constructive learning, students by learning by doing, thinking and reflecting. Teachers should pose rich tasks that are open-ended and allow for multiple entry points and solution strategies. Student-centered learning focuses on learners' active participation. Students are encouraged to explore questions and construct meaning from their experience. This method supports conceptual understanding, enabling students to make sense of mathematics through discovery, discussion, and reflections. Now here, this is an activity which can be taken up for the collaborative work. That is, the class can be divided into different groups. It's a relay race, whatever be the topic. For example, I have to make sure that the child of the class understands the Heron's formula, which starts from identifying the sides of the triangle, then getting the value of S, the semi-perimeter, then working out with S minus A, S minus B, and then finding its square root. So we divided, this is the activity which we have taken up. And I found that this activity has really helped. That is, the starter child, whoever is the starting, that's the starting point. Here we have a box with different numbers written on it. They represent the sides of the triangle. So if the child, whoever is the starting point, this is the first team. That's the first team that we have. The first team, first member will select 3 numbers which can form a triangle. Randomly, it has some 10, 20 numbers in that box. The first team member has to select any 3 digits from it, which has numbers, which will make a triangle. So he's aware which 3 numbers can form a length of the sides of the triangle. Only then he can go on, pass on to the next athlete. That is player 2. There they will work together, the two of them together. Once he brings that 3 digits, the two work together to find out what S is. S is the semi-perimeter. So they together work out and get the answer. Now the third player goes ahead with to the third player. Second player goes ahead with the third player, and there they can compute S, S minus A, S minus B, S minus C. So this computation part, if the child is aware about the different factors of the numbers, if he is aware that the numbers are multiple or divisible by, so they can take up that factor form and then get the answer, work out the fourth with the fourth. The third player will come to the fourth place and get the area together by applying the formula of under root of S, S minus A, S minus B, S minus C. And the fourth player will come to the finishing. So whichever teams comes first will be the winner. So this way we can divide the class into different groups for this activity. This is also very good activity. So for this, actually the planning has to be done for the whole year in the beginning. The teacher must be knowing how to integrate each topic. They should be able to incorporate the previous learning. Innovation, we need to understand the difficulty level of the topic of the question, or then it should be emphasized how to take up the effective method to make the concept easier and that can be understood. This is another strategy, that is the right strategy. That is, red stands for stop, amber stands for think, green stands for start. That is, the child needs to be helped here. The child is not able to go ahead. He feels stuck up. So we need to give that scaffolding. We need to encourage them, either with the help of the peer group discussion, whichever. There he gets to start and then goes ahead. So this is to be implemented in the class. So this will help us, the child will help the child come to know that is the child's assessment, where the child is, what planning has to be done for the child, how to monitor that, and how to take up the reflection part. Strategies for learning mathematics, this is for the student, that is visualization, reasoning, and number sense. So I've taken up certain videos.
You can also find this with simple algebra by setting y equals 0 and rearranging.
Expressing the polynomial x squared minus 1.
What about the equation y equals x squared plus 1? This equation doesn't appear to have any roots. It never touches the x-axis. This is backed up by algebra, where x becomes equal to plus or minus some square root of -1.
So what we find that when we have x squared plus 1, the curve does not intersect. So the child is aware that when the curve intersects x-axis, it's a 0 or the roots of the equation. Now, when you have x squared plus 1, there's no value on this which we can give us square of that added to 1 will give us a 0. So it will never intersect x-axis. So it has to be like it's under root of -1. So what is that we have from here?
You imagine some number, I, such that I squared equals -1, or I equals the square root of -1. This allows us to solve our equation as x equals plus or minus I. Problem with this idea is that it seems like complete nonsense. Where is the number I on the number line?
That's a question.
Well, perhaps we start by considering I squared, or -1. Notice what happens when you multiply some number n, which is represented here by 1, by -1. You move to -n. If you repeat this action, you return to your original number, n. In some sense, then, a multiplication.
So what is observed? When any number is multiplied by 1, it's represented on the side. But if you multiply it by -1, its direction changes. And further, if you multiply it further by -1, it again takes the same rotation, the same direction, comes back to the original position. So what is the information that you get? That's the information.
Then, the square root of -1 should be half the rotation of -1, making I a 90-degree rotation. Similarly, -I must be 180 degrees from I. This appears to create a new axis. These two axes, the real axis and the imaginary axis, together are referred to as the complex plane.
That's how we get the complex plane. Now, this is regarding the ratios. We have it as a circular function. Any point P, how is it defined? We take the radius of the circle as 1. So PM on OP is sine theta, hence PM represents sine theta. Likewise, OM upon OP represents cos theta. So the point P represents, what P represents is cos theta, sine theta. Now, if you look at the triangle POB, you'll find that it is similar to the triangle POM, and hence we get this information that PB becomes tan theta, PA is cot theta. So we have all ratios in this figure. One more slide I'll show, and then if there is any question, please don't hesitate.
We look at it from the side. So rotating the giant wheel towards us until it ends up looking like this. As you look at it from the side, it just looks like a vertical line. Here are the two views, A and B. Now, as the giant wheel rotates, the movement of the red square in view A is just in a straight vertical line, going up and down, and in view B, just in a simple circular motion. So we just took a two-dimensional motion on the right in view B with both vertical and horizontal components shown in blue and turned it into a one-dimensional motion, just vertical, as seen on the left in view A. So we start at time 0. In 5 minutes, you reach the top of the giant wheel. In 10, you're halfway around. In 15, you're at the bottom. And in 20, back to your start or
Likewise for the cosine function also. So it starts.
So here we go. This blue curve is a cosine wave. Again, notice the movement of the blue square is just up and down vertically. When plotting this vertical movement on a time axis, which is horizontal, where sine waves oscillate back and forth from the equilibrium to a max amount in either direction, which is called its amplitude, a cosine wave does the same, oscillates back and forth from the equilibrium position, same as a sine, but just starts off at a different position. Lastly, let's talk about what the word co means in cosine. Co is short for complementary.
Now, there's a question. This is an equilateral triangle. AC is the hypotenuse. We have never come across this result. That is, AC is AB plus BC. Have we ever come across this result? What is shown in this figure? We have actually divided this AC into small steps. This length, if I take it as horizontal length as x1, this x2, x3, and all these horizontal lengths, when it's added, it adds up to BC. Likewise, the vertical length y1, y2, when it added, we get AB. So isn't the length of AC x1 plus y1 plus x2? So won't it be equal to AB plus BC? It's a mathematical paradox which needs to be solved, right? So we finally get AB plus BC as AC. So what is that we have? Incorporating collaborative approaches and multiple representation in mathematics education leads to deeper understanding and more meaningful learning experience for the students. So let's appreciate the beauty of mathematics, connect mathematics to day-to-day life, make use of innovation in the learning strategies, develop joy in learning, and use technology to enhance learning. Thank you. If there is any question from the participants, I'll try my best to answer.
Thank you, ma'am. Thank you for such an enriching and insightful session. And, these experiences and the deep understanding that has certainly opened up new dimensions for us as educators. And we're deeply grateful for your time and humility and the passion for that you have for empowering the educators over here. I must appreciate all the participants over here who are, so actively participating in the chat box. Participants, now we open the forum for your reflections and questions. Please feel free to share in the chat box or raise your virtual hand, and let's engage and clarify any doubts if we have while the learning is still fresh. Yes, you can raise your hands so that we can go ahead with that.
Jyoti, you may be having a few questions gathered from the registration form, right? You can ask those questions.
So please repeat.
Ms. Jyoti, you may have those questions. No, we got it from the registration form.
Yes, definitely. I do have the questions. I was just looking forward to if we can have.
There are hands up.
Okay, so we have 2 hands up. Let's see.
Yes, ma'am. Ankit Jain here from WebGear High. I just wanted to clarify, do we have to pay that 150 rupees for a certificate, right?
Yes, if you want.
Okay. Yeah, sure. Thank you.
Okay, thank you, Ankit sir. So we have more questions from the participants that we have received. Ma'am, if you could clarify them. So how to inculcate 21st century skills while teaching class 10 students? This is one of very interesting questions.
Definitely, it's a very interesting question. Did I stop sharing?
You have stopped sharing.
I'm sorry. So it's right over here first. This is one hands-on activity. This is one activity which can have, like, you change the positions of each of this. We have it as -1, minus of this is something which will give us an idea. See, the direction of the graph has changed with one change in value. So these skills, when they're aware of taking up the things in the right way, obviously the soft skills will be developed. They'll be able to handle the things and they'll be able to communicate to get to help to others also. So we need to develop certain skills or ways of techniques to take up different ways to help them to take up the questions and take up in such a way that they are able to develop the soft skills or 21st century skills, which will help them to be a better citizen. Hope I have answered the question.
Yes, ma'am. Thank you. I think that helps the educators. So another question we have from Prema ma'am. She raised her hand. Prema ma'am, if you're still there, you can ask your question. Prema ma'am, are you there? Okay, meanwhile, she appears on the screen. We have another question. How to teach word problems to the children in an easy way?
That, remember, I had given this question. Make them understand the language of each symbol that they are taking up. Only then that language can be, if they are understanding the language, they can convert it into symbols. If we keep on reading it as 3 + 5, the child will not understand the meaning of the statement 5 more than 3 or 3 more than 5. The word has to be connected with the representation. Likewise here, 2 times this whole thing, that is twice of this expression. The language says that it's twice of the expression that we have. So the language of this statement is 7 more than twice of 4 less than 3x. So if they're able to communicate this symbol through language, I don't think they will have any problem in taking up the language to representation. Getting it? Every language, every question has to be read as a language, not as a symbol. We usually read this question whenever we give it to the child or to the class. We read it, solve the equation. The equation is 2 multiplied by, in bracket, 3x minus 4 plus 7 is equal to 11. That's not the way. That way, if you read out, we are just decoding these symbols. Instead, we need to read out when you want that the child should write this statement, you should always make the statement for this expression, which the child will be able to interpret in terms of representations. So the language is most important thing in any content, whichever topic you are taking, make sure that you are able to develop a language in it. All the representations should be said in the form of a language.
Ma'am, good evening, ma'am.
Yes.
The question which you have asked, only I want to ask you, ma'am. So you have very clearly told about whatever queries I had. So my queries have gone down, ma'am. Every queries are deleted, ma'am. Thank you very much for an excellent session. Really, I liked it very much, ma'am. And as an educator, as a mathematician, each and everyone should inculcate whatever you have said here to be in the classroom, ma'am. That will be definitely make the children to learn easy as well as they can do wonders in mathematics, ma'am. This is what I require. Thank you very much for the session which is conducted. All the team members, I would like to congratulate and my hearty thanks to you all. Thank you.
Thank you.
Thank you, Prema ma'am. Your words mean a lot to us. Ma'am, we have another question. How can we motivate slow learner to learn maths?
Again, collaborative. That point was there, no? Collaborative learning. We'll have peer groups such that high achievers, they are given the responsibility. Pair higher achieving students with those who need support. So the children, the peer group, they are easy to interact, they easily interact with their peer group. So you have to identify in the class different levels. There are different types of children. So we'll have to identify, but we need not have to tell them, we need not have to express it in the class. Never express this part in the class that this is how it has been paired. That should be in your mind. To pair a higher achiever student with a group where different, the group that you're making for any collaborative work should have types of students. The types of students means one who is good in computing, one who is good in expressing the language, one who will be helping each other to. So all this together, you have to identify. As a teacher, it's a very good, important task and very Herculean task. But we need to identify such type of students, and only then you can make a group. Please do not break the group in terms of roll numbers or high scorers with low scorers. No, you have to identify that is out of the 50 students, if there are 5 students who can express things in language, who can express things in representation, who can draw certain things to express it. So make group of those students, identify those and group it accordingly. So that pairing will definitely help to take up the peer tutoring properly. That is a collaboration work.
Thank you so much, ma'am. That helps a lot, I suppose. The next question is how to include STEM in higher grades in mathematics.
That though I'll require another class because I usually take up all the different ways of teaching. I personally don't believe in, like, if you can understand the statement, I'll explain it through this. There are so many things to discuss for STEM, but in a smaller sense, that is, we all know about this expression, what it stands for, isn't it? Most of all are mathematics teachers, so they are aware of this. This represents an angle. So we are aware of the angle that has a sine function, which is a ratio is 1/2. The angle that is corresponding to this is pi on 6. Fine. So if we are given a question which is saying that you take up the sum of these two values, so we know what this information is. They are looking for another angle which will give us the ratio as negative. So cos function's negative is, we take it as pi minus, this is also pi on 6. So total together, the resultant is pi. So this we could easily get it through this combination. Now, if suppose you are given this question, sine inverse of 1 on 3 and a cos inverse of minus of 2 on 5. Now, what about this question? How do we handle this question? Every ratio's angle is not, it's not possible that we remember all the angles. So what I tell my children is, we take it in the form of a triangle. Let's make a right angle triangle which is corresponding to this information, that is, this represents an angle alpha. So we have a triangle. The triangle is such that its height is 1 unit and the hypotenuse part, that is, if this measures alpha, this is 1 and 3. It's a right angle triangle. So obviously this side represents under root of 3 square minus 1, that is 8. Likewise, this also will represent in the triangle. But before that, as we have seen that we are representing it in the triangle where we have taken only the positive values. They are the sides of the triangle, obviously the positive values. So how do we handle this negative sign? So we need to tell this to children about this property, that is, it is pi minus cos inverse of 2 on 5. Fine. Now this will be another triangle. This represents another triangle whose base happens to be 2 and the side hypotenuse, that is 5. So this is another triangle which will name this angle as beta, for which this is 2 and that's 5. So the height of this will be under root of 23. Fine. So actually we are dealing with the question of alpha plus pi minus beta. Now to evaluate this further, we will need to use any of the ratios. So we will use any ratio that we can take up. And since we are combining, again, that's the problem. That is, we have it as pi plus alpha minus beta. So whenever we have a combination of two angles, we prefer to go for the tan ratio. So we consider this expression as tan of pi on, and then we write. So from here, if we go in, so we have actually taken up the basic things. And we have taken it to a different level without the help of any of the formula. So we get the conclusion, that is, the answer part will always come out to be correct. Do I need to explain this further, sir? Is it okay?
I think it should help. The educators on Mite may ask if they are looking forward to it. If someone has a question, please ask your question. You can raise your hand further. Okay, so I think we'll go for another, on request of the educators, we'll go for another session, as you said, for STEM. So the last question which I would share with you, ma'am, is please help us with how to teach integers in a simplest way. I know you've touched upon the topic. If you can just throw the light on the same again to reapprise.
Integers, what do you mean by integers? That is just the number part. We can use integers like we have integers as these numbers. They are representing integers 1, 2, 3, and so on. They represent on one side. Then we have a 0. Then we have negative numbers. So how should we start these numbers? What type of examples do we need to explain to get to this? The first example of how to start this, we take it through the operation. We have, that is for integers, the child is aware about natural numbers, the child is aware about the whole numbers. So they are aware of the operations, addition, subtraction, and all. So when your child is getting this operation 2 plus 3, he knows what it means. That is 3 added to 2, which gives them 5. Now, if the child is given this operation 5 minus 3, that is taking 3 from 5 is giving you 2. So he is able to get it. But again, the question is, what if or how can we take out 5 from 3? That's the thing that we have to make. So 3 minus 5 means you're taking out, because that's how we have explained 5 minus 3. That is taking out 3 from, or how much is 5 more than 3, or how much is 5 is than 3. This is the representation. So how do we express this? This is explained through integers. That means we have next set of numbers which will cater to this, which again, real life situation, you are on the ground floor, which represents 0. You climb up a building, it's on the first floor. Then you climb up next, it's on the second floor. You climb up, you get on the third floor. Now, after reaching third floor, you click the button of -1. That is -1. That means you're coming down once. This is a 1 step down. So you'll be at 2. At 2, you click this button. There are 2 switches. That is -1 and +1 are the switches. You switch. Click on this switch 5 times. That is, you'll have to move 5 steps back. So when you move 5 steps back, you're coming down the opposite direction. And that is giving us information of the negative numbers. So through this, you can always introduce the integers. And then further with this operations, we can carry on with the integers. All the operations can be taken now. Or more you require, anything more you require regarding this integers?
No, I think that serves the purpose for today's question. Thank you so much, ma'am. These inputs are really going to help us, and we are deeply grateful for your time and the real life situations that you have shared with us and the solutions they're going to help our educators in their classroom experience. So, dear participants, kindly note that you can log into www.vtag.in to download your certificates. And now we're moving forward to conclude the session. So as we conclude this powerful learning experience, I extend my heartfelt gratitude, first of all, to our resource person, Dr. Beena, to be here. Thank you so much for being here, ma'am. To Dr. Abdul Salam, sir, and Mr. Pillai, sir, for their inspiring leadership. To Dr. Beena Prakash for her masterful and generous sharing of knowledge. She has been so kind to answer all the queries and even go through the minute details. And to each one of you, thank you for your attention, curiosity, and commitment to growth. Your involvement inspires us to organize many more exciting sessions. We look forward to seeing you at our next event featuring another distinguished resource person. Let's continue to empower our students, not just academically, but holistically, because their future deserves nothing less. Thank you once again. Stay inspired, stay impactful. Over to you, Salam, sir.
Thank you, Salam, sir, and the team for giving me this opportunity. And I don't know how much I have got into this and how much my participant or learners have got the information, but I tried my best. Thank you, sir, for giving me this chance.
Thank you, ma'am. A big round of applause to Beena, ma'am. Definitely, it was very much enriching, as it was the reflection of your mastery of the subject and your experience. So we need mathematics teachers, need teachers like you, educators like you. So thank you so much for spending your valuable time. We know we have been.
My pleasure, sir.
We have been postponing this because of non-availability of time and all. So thank you so much. And Miss Prema has vouched for your session, right? She has aptly reflected on the session. So thank you so much once again on behalf of all the participants, and at the same time to Jyoti ma'am also. Thank you so much for your gracious moderation and your help rendered to Miss Beena Prakash. And also we should appreciate the educators, the participants who have who have remained for this nearly 2 hours with us. Right. Thank you so much, participants, for your enthusiasm for learning. Definitely, we will try to request Madam to have one more session for all the educators on various other aspects of mathematics, how to deal with the transact and all. So thank you so much. If Madam, if you have time, Veena ma'am, if you have time,
Definitely,
please
sir.
think
Anytime.
about.
Now, anytime.
Yeah.
I
Think
was
about
really,
a
I was
topic
really
and
packed with little pre-assigned work tasks. So
yeah.
next time I'll try.
Okay. Thank you so much. Thank you so much, ma'am. Thank you. Thank you, Jyoti ma'am. Thank you, everybody.
Thank you, sir.
Good night. Keep connected. And there is a there is a trouble in our website showing server issue. No problem. You can use the second option. There's a second option. By manually, you can fill up for the certificates. Thank you so much, everybody. Good night, ma'am. Good night.
Thank you.
Yeah. Thank you.